Unlike real numbers, in algebra we use symbols. And symbols have special rules of addition, multiplication, division, and subtraction. In this respect, the very first thing that we are going to learn is the concept of like terms and unlike terms. Like, if you have two men and three men, then how many men are all together? You definitely are going to say that it's not difficult. 2 men plus 3 men are equal to 5 men. Interesting. But what about this question? If I write 2 men plus 3 birds, what are you going to say? 5 birds or 5 men? No, because birds cannot be added to men and men cannot be added to birds because they are unlike. That's exactly how we follow rules of addition in algebra. We first identify which two terms are like so that they can be added. Like example 1 here. In example 1, 2 men, this term is like 3 men. Both terms are like terms, that's why they could be added. But in example 2, 2 men and 3 birds are unlike terms. That's why they cannot be added. So in deciding which terms are like and which are not like, we got to take a look on two things. So for like terms, number 1, variable must be same. Variables must be same. And number 2, power of the variables must be same as well. Variable power must be same. So this is the rule. Let's do a few questions, and with the help of these questions, I am sure you'll be able to understand which terms are like and which are unlike terms. So example, identify which terms are like terms. And here the terms are given: 2x, 3y, 15, and 5x. Obviously 2x and 5x, this term and this 5x, they are like terms. So 2x and 5x are like terms. The reason? Because the variable x is here, the variable x is here, just like 2 men plus 3 men. Both of them are same type, that's the same variable, plus the exponent on top of each variable, which is invisible in this case, is 1. So the exponent is same as well as the variable same. So if both variable and the exponent are same, then the terms are like terms. And which one are unlike terms? So unlike terms are 3y, 5, and 5x are unlike terms. This concept is key to understanding of addition in algebra, and because you are just starting algebra, so you cannot afford to not to understand any concept. This is a key. That's why you should practice this. And let's do a few more questions so that example number 2, solve the following problems. And what is the first problem? That is 3x squared plus 7y plus 9 plus 2y plus 4x plus x squared plus 2. So here we are going to group together like terms. So guess which terms are like terms. This 3x squared and there is another x squared. These are like terms because the variable is x in both cases and the power is same as well. That's why we have 3x squared plus x squared. They are like terms, so they could be added. That's why I'll group them together. Plus, is there another term like 7y? 7y and 2y, they are probably like terms as well because both have the same variable y and exponent for both of them is same as well. That's why we have 7y and 2y. We can group them together because they are like terms. And now, is there another term like 9? This is called a constant term. Its degree is 0. So plus 9 and 2 is another constant. That's why 9 and 2 are like terms and they can be grouped together again. And now the only term left is 4x, which is unlike any other term. That's why it must be written separate. So here, this is in next lesson we are going to learn about the rules of addition, but this is based upon, the addition is based upon identification of like terms. Let's do one more. By the way, if we want to add them, 3x squared plus x squared would be 4x squared. Remember that while we are adding the like terms, the power still remains the same. The exponent, if both exponent can be added, they both must be same and the answer will carry the same exponent. So this would be 4x squared, 7y plus 2y would be 9y, and 9 plus 2 would be 11 plus 4x. It is a very common mistake that students make, that they add up the power. Like 3x squared plus x squared, many students would be tempted to like it 3x power 4. No, that is not true, because if you look at 2 men plus 3 men, they are 5 men. There is no increase in power. So you should be careful that exponents should never be added. In another example here, group together like terms. Group together like terms, and here 10p minus 4q minus 4q minus 5pq minus 5pq minus 5p minus 5p plus 3q. Here 10p is a term. Is there another term like this? Yes, there is a term like minus 5p, because both have the variable p and both have the power 1. That's why they are like terms and we can group them together. So this will be 10p minus 5p. So These are grouped together. And minus 4q is just like 3q because both have the same variable. That's why we can group them together as well. Minus 4q plus 3q. Minus 5pq. This is a product term of p and q. So remember that its degree is additive. When p and q are being multiplied, their powers will be added to determine the degree of the term. This term is unlike any other term and its degree is 2. By the way, what is degree of the first term? The degree is the sum of powers or exponents of all the variables present in that term. So this minus 5pq is unlike any other term, and that's why it should stay separate. Before we end this lesson, let's do one more question. Here is 2h square k. 2h square k plus 3h square k plus 2k square h. So group together like terms. So if we want to group them together, here 2h square k individually look. First you got to take a look on individual symbols. Here h square and here is h square. That's not done yet because there is a k there. There is a k and there is k. Individually h square and h square, they are like, k is like k, and their product, the degree of this first term is 3, the degree of second term is 3, h square is like h square, k is like k. That's why both of these terms are like terms. But look at the third. This is k square. There is no k square in any of the first or second term. That's why that is unlike term. So if we want to find out or group them together, we can group 2h square k plus 3h square k. They are like terms, plus 2k square h. It is unlike any other term. That's why it should stay separate. And if we want to add them, we can add them and write 5h square k plus 2k square h. And here in the previous question we could write 5p, and here minus q plus 5pq. That's how we can add like terms and leaving separately unlike terms. This concept we will continue to work on this concept in the next lesson as well.